have two type of precedence. The first is the good precedence, the forward precedence. The second is the bad precedence, means the drop precedence. In forward precedence, the higher value is better, the bigger is better logic is available, and in drop precedence, the bigger is better is not available. The bigger is worse. It's important. Okay, now let me talk about the different values that we have. In the AF, we have 4 classes of forwarding. We call them AF1. I will talk about them. AF1, AF2, and then AF3, then AF4. Assured forwarding 1, assured forwarding 2, assured forwarding 3, and assured forwarding 4. Okay, I will talk about them. But first, let me show you the different values that we have in this condition. For example, you know that in the first forwarding class, this is the first forwarding class, this is the second forwarding class, this is the third forwarding class, fourth forwarding class, and so on. Okay, in the first forwarding class, we can use the next 2 bits with this value 0 0, and you know that the 6 bits always is 0, and then again 0 0 0 1, okay, and then 0 again, 1 0, and then again 0, and finally 1 1, and then 0. This is the forwarding class of 0 with different, okay, drop precedence. Again 0 0 1, again we have this condition 0 0 0, then 0 1 0, and then 1 0. And then it is so important, you need to carefully think about this, because it is so important for configuration of the classification and marking. And then 1 1, then 0. Also in the next forwarding class, we have these values 0 0, and then 0 1, okay, 0, and then 1 0 0, and then 1 1, for example, and finally 0. And after that, the next class is 0 0, then 0, after that 0 1, then 0, and after that 1 0, okay, 0, and finally 1 1 0. And after that, in the next class, I'm going to use again 0 0, and then 0, and after that 0 1 0, 1 0 0, and then 1 1 0. Okay, this is the next forwarding class. Also, let me to write for the 1 0 1 0 0 0, then 0 1 0, after that 1 0 0, and finally 1 1 0 0. For the for example, other forwarding class also we can use these values, but let me to use only 0 0 0, and also here 0 0 0. That's it. If you want, you can complete them. It's not important. Look at here. You know that this value of the DSCP is the CS0. It has the value of 0, okay, and this value has the value of 2. For example, 2. If you calculate this value, it is equal to 0 0 1 0 equal to, then this is 4, this is 6, okay, and then 8. This is decimal equivalent, 10, 12, okay, 12, and then for example 14, and then 16, and then 18, after that 20, 22, 24, okay, and then 26, and after that 20, for example 8, and after that 30, and then 32, okay, and then 34, and then 36, and then 38, and finally 40, and then 42, 44, okay, and for example 46, okay. And also here, for example, we have the, you know that here we have 132, and then 16 equal to 48, and this is equal to 56. Okay, here we can see the values of the in decimal. Here we can see the binary. Let me write here, and after that here we have the decimal value. So easy. After that, you know that in the previous part we have learned that this is equal to the for example CS0. You know that the DSCP0 means CS0 or default. This is the CS1, okay, and this is the for example CS2, and after that this is the CS3, and after that this is the CS4, and then this is the CS5, and after that CS6, and then CS7, okay. But Now let me to explain some of these values. For example, let me to explain the value of 12 and also the value of the 20, okay? 12 means 001, this is one DSCP value, okay? DSCP 001 and then 100. This is equal to the 12, okay? And also we have another value. The next value is the DSCP of the, for example, 20, 010, 100. This is 20. I'm going to ask you which DSCP has more priority of forwarding, about the forwarding. You can say that about the forwarding, okay, for example, priority, the DSCP 20 has more priority in compare with the, for example, the 12, because here we have 010, here we have 001. Okay, but if I ask you about the priority of the drop, you can say both of them are same, because both of them are using the same priority value. Okay, let me to give you another example. For example, in the 20, okay, I'm in the next example, I'm going to use the DSCP 22. In DSCP 22, this value, we are using 010, then 110. Again, I'm going to ask you the first question. Which traffic, which packet, with this we have two packets. The first packet is has the DSCP of 12 and the second packet has the DSCP of 22. I'm going to ask you which packet has higher priority about the forwarding. You can say the 22 DSCP packet has higher priority because the first 3 bits has higher value. It's okay. Now I'm going to ask you which packet has higher priority about the drop. When we are experiencing congestion, which packet should be first dropped? Again, the answer is the higher priority of drop is related to the 22. Why? Because the 22 in the, for example, these 2 bits has higher value about the 10, and this means that always the higher priority of forwarding does not mean okay to the lower priority of drop. These two functions are independent from each other. You should consider them independently. First, for example, when you are thinking about the forwarding precedence, you should watch to the first 3 bits. When you are thinking about the drop precedence, you should, for example, notice to these 2 bits. It is so important, but it is a little hard to remember or to use these values. For example, when you are configuring in one complex scenario, one complex real network, okay, the DSCP values, it is hard to remember that the 20 or 22 has higher precedence than the CS1 or the, for example, the 12 in the forwarding, but has lower precedence in, for example, or higher precedence in drop. It is not so easy remembering all of these features, okay? Because of that, we can use the codes of the RFC 2597. Let me to talk about these codes, the AF codes. In RFC 2597, we have 4 class of forwarding. Here, AF1, AF2, AF3, AF4. This is the AF1 class of forwarding. You know that all of these 3 codes, 01, 10, and 11, are residing in same class of forwarding. They are different about the precedence of drop. And 18, 12, and 18, 20, and 22 are residing in AF2 class of forwarding because the first 3 bits of these 3 precedence are same, AF2. And after that, we have the AF3. This is the AF3. Okay, this is the AF3, so easy. And also, finally, we have AF4. This RFC defines 4 class of forwarding. And also, you know that in each class of forwarding, we have some class of drop. You know that about the forwarding, the 10, 12, and 14 is same, but about the drop, here we have differences. For example, this is AF11, this is AF12, okay, and this is AF13. What does it mean? It means that the AF11 and AF12 and AF13 are using the same priority about the forwarding, but the priority of drop of the 14 is higher than, means it is worse than the 12, okay, and worse than the 10, means AF12 and AF11. About the forwarding, all of them are same. About the drop, first, this traffic should be dropped, the AF13,